Hello, friends. Yeah, just give me a moment, please. Okay, good. I believe we are live now watching this. All right. Hello, friends. Yeah, just give me a moment, please. So, we want to look at several tasks right now. We're looking at several tasks. I've applied some of the questions down ahead of time. Okay. So, these questions are more related to the second task of the variables aspects of ALXC programming. All right. Then this first task actually focused on the aspect of getting random numbers. So before I start really talking about how to go about solving the first task, I would like to mention some certain functions which you will need to consider knowing first, even if they told you to ignore it. You shouldn't still ignore that because it's actually very important. So we have the rand function. Okay, let me take this stuff up a bit. So we have the rand function and we have what we call the rand function. So the first one, the rand function, what it does is that it just brings in a random number. Okay, and the random number is always from 0 to rand max. Now, this rand max is actually a number, okay? So it's actually a number, and it's just more like it's something they defined, okay? So this rand max is actually something defined. You may not understand what that defined word is, but later on, so you'll get to understand how to define certain things. So the rand max actually represents a number, okay? So depending on your OS, I think for 16 bits operating system, which I believe most system are not using 16 bits. I think most system are using that 32 or most especially 64 bits. Okay, so the minimum number or the minimum value of this rand max is 2000 is 32,767. So that means I'm saying that a random number will come out from 0 to at least 2007. In terms of 64 bits, it's up to a million. It can be from 0 to up to about millions. Okay, so that's just what rand function does. It just bring in a random number for us. So now rand function. So what this rand function does is its own work is just to initialize the program. When I say initialize, it's like repeating the runtime of the program. Like if you don't put this rand, for example, and you run and build your code, like test your code, it will only bring out the random number once. And if you build it again, it will show you the same number it brought the other time. It won't change it for you. So if you want to have this recurrence changing whenever you are clicking run, you want to be seeing new random numbers. That's when rand comes in. Okay, so it helps to initialize the program as if you are starting it afresh and trying to run it again. That's how it seems like. So that's what rand do. And this rand has a syntax. Let me just write the syntax of this rand. So the syntax is void rand unsigned unsigned probably later in the video while we are going you get to understand what that unsigned mean. Okay, but I'll still explain it in a straightforward way, not going in depth anyways. So this is the syntax for rand. All right, so syntax. So that's the syntax for Silan. So the void is just like saying anything can be there, like any kind of like declaration can be there. It can be an integer, it can be int, it can be char, that's char, okay, it can be float, it can be something. All right, that's what that void means. So this is the Silant function itself, and inside the Silant function, we have to put this unsigned integer value. Okay, now unsigned means that we are forcing the value that will be inside our function to be a positive number. in terms of this Sirand itself. All right, so we're forcing it to be a person. That's what unsigned mean. All right, so you later you'll get to see what unsigned and signed mean. Okay, signed, for signed you can put positive or negative number, but for unsigned you are forcing it to be positive number. All right, so that's just the difference between the two of them. So going on, okay, so then we have the int, we have seed. Well, this seed just means kind of like a number value, which most time we usually use the function, the time function for this. Okay, so we often use the time function to represent that aspect there. So anyway, we are going to see a good example of how to use this whole function. So I just chose to like explain what this two stuff means. That is the rand function, which is the major primary function, then the surround function in terms of initializing it. So I can be seeing repeated random numbers whenever we are running our program. I think that is enough in terms of explaining what this concept means. So let's go to our first task, task one. All right, so in this our task, the question said this program will assign a random number to a variable n. Each time it is executed, that means this program will assign a random number to a variable n each time it is executed. That means anytime we execute the code, whenever we want to run it, it should be bringing new number. And what did I tell you about the condition if you want it to be bringing new number? That's where Siran comes in. So you need to put Siran. So if you don't put Siran, it won't bring new number each time. It will only bring a value once and it won't change the number anymore. Okay, so if you want to make it to have repeated random numbers each time it is executed, that's when you now need to put that Siran. All right. So complete the source code in order to print whether the number stored in the variable n is positive or negative. All right. So once you complete the source code, well, from what if I to be using directly ALS question, you will notice ALS give us a demo of the Siran and everything down for us. So that's what they mean about we completing the source code, which is already given to us. So I'm just going to type them raw here in this sense. And sure, before I even do this task, let me just do a normal example that doesn't really concern this ALX first task, just so you understand what this whole Siran stuff means. So let me say standard input and output header. Okay, since we're going to use time function, I'm going to include another header called time.h. All these are standard headers. Okay, so I want to run everything in our main function. Okay, so int main. All right, so what I want to do now, since I want to bring in random numbers, so me bringing in random numbers and I'm using n to declare those random numbers. Okay, so that means I'm going to use the for loop. I don't know if you guys have done for loop, or if you know what for loop is. Sure, let me just quickly talk about for loop because we are surely going to be using it. So this is like part of what I am, part of the new things that I said I will be saying here, which I'm yet to do their own unique videos for. So I'll just give a short summary of what for loop means. So for loop is just something that keep like reoccurring, reiterating, like keep going till it meets certain condition. Okay, so it starts with an initializer, okay, so which I just call initialization. Then it has the next part is the condition for it to stop or for it to continue, while the last part then is the iteration. So this is just how for loop works. All right, so we have the initialization, and we have the conditional aspect, which is at the middle, and we have the iteration aspect, which is at the end part. Okay, so that's what for loop is all about. Now now going back to, or probably let's not go, but I say I wanted to just do a random example first about how to use this Sirand. So let's say for example I want to print 5 random numbers from 0 to 49, for example. So if I want to print random numbers, 5 random numbers from this one, I'm limiting it from 0 to 49. So the way I'm going to do this is then, and I want to do it repeatedly. So it will be anytime I build the code, it should give me that repeated random number. So as usual, I'm going to write the Sirand for that to happen. All right. So I'm going to put my Sirand Then just following the syntax which I have explained the other time. I said we have the unsigned, we have then the int time, where you don't need to put that int anymore since time is actually our header here and it's an integer value. Okay, so surround. So I'm going to put my unsigned word here, then space time. Now this time you can give it a null parameter, okay, or you can give it 0. Either one you give it is still saying the same thing, because a null character is still the same thing as saying 0. So I have mentioned null character before now in one of my videos there that I said all its bytes are zeros. All right, so let me just use this null. So I'm going to use that null semicolon. So this is just the only thing you need to do in terms of surround. So you're actually complete here. Okay, so probably maybe one more thing you can then choose to want to do is that since I have or better still, let's just go on this way first. Okay, let's go on this way first before I start my. So let me just label this aspect, so I'll be getting each of the step. I'll say this one is initializes random number generator. So this one is just a way of getting random number every time. All right, so now the major focus of our task which I want to do here is that we want to print 5 random numbers from 0 to 49. From 0 to 49. All right, so that's the goal that we want to embark on now. So for us to do that, I would then need to use the for loop. Sorry, I would then need to use the for loop, and the for loop will go from 0, which is our starting point. Okay, so 0, which is our starting point, down to the extreme end. That's our rand function, which I just chose not to give it any value at all at this point. Okay, so I'm going to say I equal to 0, which we are initializing as 0. Then the condition of where it should stop. Remember, we're dealing with 5. So we're dealing with 5. That means our n. I'm trying to say all these are equal to here now. I mean, this conditional aspect. So if I say I then will be less than n, then the next part is the iteration part, plus plus. Now let me just show you something here. Let me just go back here. Since I've introduced that n here as a condition, remember the I is this 0. So any place you are seeing I, it means it is replacing with the number. This plus plus means it is adding. That's this 0 will start from 0. The I will start from 0. Next thing to start with 1. Next thing 2, 3, 4, on and on. Okay, it will be counting that way until it meets this certain condition at the middle. So I have an n here and I've not assigned anything to n. So let me assign n as 5. Okay, so I'm assigning n as 5. And since n is a variable, so I have to declare the variable of n. So n will be integer, which is a number. I even have I here. I've already declared I as 0 here. So I have to also, assign I as 0. So I have to put the declaration of I also. Okay, I think we are good this way then. All right, it's good. So next line then let me put my curly brackets. So now we want to print the numbers, that's the random values. Okay, and this time we want to print them using the rand function. Remember, rand function is for us to print those random numbers. All right, so now this %50 is just a way of us limiting it to 50. All right, so when you say print 5 random numbers from 0 to 49, okay, so we're saying from 0 to 49, we're saying 50. Remember, we're actually, okay, there's one thing in programming. Let me just put this, let me just quickly say this one. The way in coding numbers things are different at some points, like especially when we're numbering strings or we're numbering arrays. So if you notice, we said 0 to 49. Now, this 0 is like a number. like number zero. Just put it that way in your mind. So that kind of number zero. Okay, so that means we have other 49 numbers plus zero, which make it 50. So it's not as if I must put 49 here or trying to make here as 50. It won't work that way. So that extra space just needs to be there in a way. Okay, so that 0 to 49 is still all total is still 15 numbers as a whole. Okay, just get that part at the back of your mind. Okay, now if you notice, we declared n as 5, and the condition here is saying that the iteration should stop if I is less than 5. That means the iteration should continue when I is 0 times. When I'm saying about iteration continuing when I is 0, I'm trying to say that, I mean, like, once I run this stuff now, it should run for me 5 times. But then I put 5, like I place 5 inside here. Ensure that I may not even need to even put this n that I placed here. I can just choose to remove this n and just put that 5 directly inside my conditional statement, and to still work neat and fine. So minus 5. So it will run 0 to 4 times. This condition will run 0 to 4 times. Remember, the initialization I is 0. So which is 0, 1, 2, 3, 4, 5. And because of we are asked to print 5 random numbers. Okay. So 0, 1, 2, 3, 4, which are 5 numbers. Add that 0 as a number. So you see that there are actually 5 random numbers. All right. So lastly, we are going to add our return 0. So that's our return 0. Yeah, don't forget to put the semicolon after the printf function. So I think this code looks fine. Let's see if it will run, or if there's any error, we'll find a way to fix that. Okay, good. There was no error. That means it actually will run smoothly for us. So as you can see there, we have 43, 19, 27, 17, 8. Now I'm going to close this and I'm going to run it again, just so you see we're having another different kind of like answer. You can see we're seeing different answers. You can see now 15, 8, 22. Let me run it again for the last time. You can see another number now, 32, 12. So that's just what that run does. It keeps making it like update, changing the stuff. Okay. But if I remove that run and just run it like that, just give me a fixed value. Okay, it's just give me a fixed value. It won't be giving me repeated changes whenever I execute the code. So this is just like a brief summary of what the whole concept of Serand is talking about. So I just believe you understand this explanation well. So now I believe from this knowledge now we can then move to that our tax one. Okay, so let's move to our tax one. So our tax one, let me go up. So the question said this program will assign a random number to the variable n each time it is executed. Complete the source code in order to print whether the number is stored in the variable n is positive or negative. Now, the output of the program should be the number followed by, if the number is greater than 0 is positive. If you greater, now all this stuff, if we're talking about if statements. Okay, I'm yet to create a unique video for if statement though, which we still call like conditional operators. Okay, but let me just briefly say one or two things concerning that if statement now. So if statement, even from the way it sounds, say if this one doesn't happen, do this. If this one doesn't happen, do this. So that kind of, it's just like normal English. Okay, and yeah, I just remembered one more thing here. Sorry, let me go back to, now if you notice something here in this my for loop, I put a curly bracket here, and you should do that. Most times we do that whenever we have more than one functions that I want to put inside here. Okay, but since we have a single function, which is this printf function here, I can still another way just remove the curly brackets and just leave it this way, and it still runs successful for me because we have a single function that is running with our for loop. Okay, I should just let you know this aspect well. Okay, so but if it is more than 4, you have to put that curly bracket. So just keep that at the back of your mind. If I build this and I can see it still runs successful for me. So that's just it. I just felt I should let you know that aspect. So now saying about if statement. So if statement comes with a condition inside of it, okay, so it has a condition, then it has curly brackets, then it can have more. If you have several if statements, then it can be like declare more of the if statement using else if. That's if this one doesn't happen, else if, that kind of statements. Okay, so you can now put another condition again here. Condition, then run the code of what you want the condition to do. So you can be doing that till probably just have a final else. Okay, so that's just what is if statement. So we're still going to see how it works using this particular task. So now let's start this task. Let me go back to my code blocks. So I will just erase time. Remember I said you can use null, you can use zero, doesn't matter. Okay, both of them are still saying the same thing. So this is one way. So declare this first, you've done well. Then the next part, well, since we're already given a demo of the source code to use directly from, okay, so let me just chip in that source code, then I will just explain the meaning of those code. Minus rand max divided by 2. Okay, now this rand max, like I said the other time, is the maximum number, okay, which is at least 32,767. Right. Now remember board mass, the predecessor, which of, and this is a mathematics, this line now is mathematics. You can see we have negative, we have division here. So remembering board mass, yeah, we can see we have the division comes first, which is our D, and the subtraction is even last. So that means it's going to divide the maximum random number. So I think for 64 bits is around, I think up to a million, okay, or more than a million, all right, divided by 2 minus the rand meaning any random number that comes out with it. Okay, let's say it comes out with 2, for example. So 2 minus whatever value you get here will give you our n. So that's what it's just trying to say. And since we have n here, which means we have to declare n, because n is a variable here. So I'm going to say int. So int n. Okay, very important. I've declared the variable int n. Also, we will need to also declare the function. So instead of me writing int rand here, let me just declare the function directly here. Because rand too has its own like syntax, which means you have to declare it also. All right, so we're declaring that. Then lastly, we also need to declare our rand max, since it's also a number, okay, which we defined, okay, just like the way we have x is equal to something, so it's like something like a variable in a way. So we have to define it as int also, since inside it is a number. We don't actually need to put int here, so this first int has covered for the rest parts of our variables here. Okay, so now we have this rand, which means to make it run different times, giving us the random number we desire. And we have the rand function, which will bring the actual random numbers, all right, then subtracting it with the maximum number divided by 2, okay, which we won't really see in our eyes. Okay, so just work inbuilt inside. All right, so the last thing for us then to do is for us to follow the other part of the question about the if statement, saying that the output of the program should be the number followed by if this, do this, if that, do this. So those conditions, if conditions, all right. So it means that whatever answer it comes out with, we are going to add. If the answer is greater than 0, we are going to say it is positive. If it is equal to 0, we are going to say it's 0. That means we are going to use printf for each of these. That's what it means. We are using printf. Just note that one at the back of your mind. We are using printf here. We are going to put the printf inside our if statement for each of them, inside the if statement. So this is how to go about that. So I will then say if for the first condition, if n is greater than 0. Okay, so if I actually wanted to put a curly bracket. I just realized there is no need because I'm only using one function after it, just like the way I explained that other example. So since I'm putting one function after it, I can close it with the semicolon at the end of that function. So print f, so I want to print whatever answer it gives. Okay, so printing whatever answer it gives merged with the statement. So is positive. So printf d is positive. I'll put a new line. Then as usual, then call the variable you are using. So we're using n. So now what this is doing is that once this our round runs, my it will now minus the maximum number. Let's say for example, this round max can be 32, 6, I think 32, I think 767 or yeah, 767. That's at least it can be bigger than this. Okay, so instead of us writing this number, that's why we choose to put this random max, because we don't know which operating system we'll be running is our code, so to bring different values for different systems. So that's just the fact. So whatever value it brings out, it will assign it to n. Okay, so it will assign that value to n. So that means now we're not giving a condition that if that value is greater than 0, we want it to print out the value and also saying that it is positive. Okay, now another condition, else if it is equal to 0, we are following the question. If the number is greater than 0, if the number is 0, if the number is less than 0. Okay, so if it is 0, we are going to add is 0 there. So let's add the is 0 there in our printf. Printf %d is 0. So we're going to put from our variable n, use your semicolon. All right. Now, lastly, the last condition we're given is less than 0. So if it is less than 0, so if else is less than 0, that is saying n is less than 0. I want it to print for me the answer. So let us actually see the answer if it's indeed less than 0, and then add that is negative. Since anything less than 0 is negative, right? And that's what the question says we should put in. So it's negative, new line, and our n. So I'm going to close this. In short, you can even, since this is the last condition, you can just put else without needing to put else if. Okay, so that else is just like the final else condition. But let me just put else if. Let me just put else, just so you won't get mixed up with different concepts. So we have else if, then you different conditions aspects. All right. So looking at this code, I'm trying to see if there can be any form of bug. Okay, this one is for us to bring random numbers. This one is where the random numbers is actually coming from. This is a mathematical arithmetic operator that is happening here, and it gives us the value, it assigns the value to n. So whatever n is, if the n is bigger than 1, this is what we'll print out. But if the n is equal to 0, this is what we'll print out. But if that n is less than 0, this is the last thing that will print out for us. So that's what this program is all trying to say. So let's run this and see. Okay, yeah, we have 11,990, which is a positive number. That's why I said that is positive. The answer is positive. Now let me run it again. And so we have another one, 12,000 is positive. That's why it's running this same one because it's greater than 0. Hopefully we're going to get any negative one. It seems this system likes positivity. So we're actually getting more positive values here. Anyway, so that's just how to go about that. And you can see the values are changing also. And the reason the values are changing is because of this rand that we have in here. Condition of this first one and this first one is not met. anyone that goes, let it print out this negative this value. That's what it just means. Okay. So let me just write this. This I just want to write it. I think I'm going to need this for the this same write up for the second task. So I don't want to stress myself. All right. So this is how the answer of the first question here is given to us. All right. So that's how to go about that. And okay, remember we use zero here, which I said you can use null. So you can try putting null here. It will still run successfully for you. All right. And there are some people that use different method in doing the same thing though. Like in terms of this time function, using this time function, they'll just put the address of t. Okay. Hey, you may not really get what this address of t means. Sure, let me not mention it because this and the later videos when we're dealing with pointers. So pointers to pointers and address, you get to understand. For this, let me just leave it basic. Okay, so just stick with this one the way it is. All right. So let's see the next one, which is number two. Okay, so for number two, this program will assign a random number to the variable n each time it's executed, okay, which means we're going to use rand. Complete the source code where we already have the source code in order to print the last digits of the number stored in variable. Now we want to print only the last digit number stored in the variable. So let me just show you example of what it's trying to say. Let's say, for example, I build this, I run this. So when I talk about the last digit number, if this is 6, I want it to now bring out 6 for me. Number here, which is 6. Okay, so that's what it's just trying to say there. So for us to go about that, then we'll need to change this our if else statement because this one has its own condition that the output of the program is this sentence. If the last digit of n is less than 6 and also not 0, then we're going to put this last one. So that's what those statements are saying. So let's just see how to quickly go about that. Okay. So I'm just going to erase. Okay, let me put the new condition here. So the first condition here in this part of before we even put the condition, let's focus on this first printf portion. So it said the output of the program should be the last digits of then a new line. So that's what we're going to use. So followed by n. Okay, so last digits of followed by n. So that is trying to say last digit of percent %d. Okay, remember n is the variable we are declaring and it has an integer. So what we're trying to say is that I'm going to say print f last digits of now instead of putting n, which is this our n here. So whatever value of n should give me it should give me that value, which is using our format specifier percent %d. So that's what it's trying to tell us. Okay. So is then looking at question again is followed by followed by the string is. Okay. So that's just it. So the is then will not give us the actual answer to it. So I'm going to give it as percent %d since it will still be a number. That means that we're taking the last number and the percent %d is for anything integer. So we're going to put that percent %d there again. All right. Then space, comma. Now each of these d arranged this way, I'm going to assign each of them using our as in give them the variable, call the variable for them. So the first one should relate with this variable n. Okay. While then the last one, sorry, while then the last percent %d, which is the percent %d, should then focus on the last number because I'm expecting to see the last number here. Okay. So the last digit can be like let me just say the last digit of 212 is 2. Let me not use 2 1. Let me say okay, the last digit of 123 is 3. That's what I'm trying to print out. Okay. So that's just like an example. So the last digit of 213, which is this first percent %d, is now this new percent %d is giving me the last number, which is the 3 itself. So for us to get a last value of anything or any number, we should use n modulus 10. That's how to get the last value of any number at all. You can just reason this stuff in mathematics, like it will make more sense to you that way. Okay. So maybe let's say for example if we have 203. Okay, and if I say the modulus 2, let me use comments. If I say 203 modulus 10, For example, let's say the random number brings 203. Okay. So what do you think will be the modulus of this? We've done modulus in the other class. Obviously, 200 we cancel out the whole of the 10, like when you are doing the division. The remainder here is the 3, and this same 3 is the last number here. The same thing if it is 2 that is here, it means it will be 2 that will print out as the last number. Okay, so that will be what we replace in this our percent d. This is our last percent d here. So that's why we are using n, whatever number there, modulus 10, all right, to get that actual last number. So I hope you understand this aspect well. Okay, you can actually there are also several ways which you can choose to still do the same thing, but let's just do it this way. Okay, no, let me just make it easier in a way. Let me create a new variable and I will just name this one last. Okay, so last. So I'll just say n modulus 10. So since it's an integer, I'm going to declare it here also. So last. So this is a variable which I named last. Trying to say like last num. So let me name it last num. That's last number. So that means instead of me putting this stuff, let me just replace it with last num. Good. So I think you'll get this, you'll get it like this better. All right, so it won't mix up. So now for the if statement, now the first, let me go back to the question for the if statement. Now, if the last digit of n is greater than 5, if the last digit is greater than 5, we want it to print something. That means what I'm just going to do is that I'm just going to write if the last digit, as if our last num variable is greater than 5. What I want it to do for me is to print what they said here. Okay, once it's greater than 5, prints and is greater than 5 and is greater than 5. So let me just erase this part and replace it with and is, oh sorry, and is greater. I'm using a touchscreen laptop, so sometimes it's touch itself. Okay, so and is greater than 5. So that's how I've declared the first one. Now the next question part says that if the last digit of n is 0, the string and is 0. So if the last digit is 0, so the next if statement, our last num, whatever it is, if it is 0, then I'm going to put 2 equal to sign. If it is 0, I've explained what that 2 equal to sign in our previous videos. So that I say you need to watch our previous videos well before getting to meet this part. Okay. So if it is equal to 0, then it should print is 0. I think that's what it said there is. Okay, and is 0 rather, and is 0. And the 0 there is the real 0 value. Okay. Now the last condition. If the last digit of n is less than 6 and not 0, okay, then print this. So let's put that statement where if the last digit of n is less than 6, so that's last num, if it's less than 6, okay. Now it's not just one condition, it has two statement condition there. Now if it is less than 6 and not 0, this and now we have this operator, this and operator in C. So and then the other condition saying and it's not 0. So that not operator also has something called not operator. Wow, we are really going in depth into some. I will try to make sure I try to create videos about this operator stuff, this conditional operator, logical operator stuff. Because this is more like logical operator. But I'll try to still explain it in a way that hopefully you still try to grab it. So we're talking about last num, yeah, the same last num. If it is not equal to 0, okay. So now what this AND operator does is that, let me just go to this part and say one thing, one or two about AND operator. And let me just mention this one again. Just this one means equivalence. Okay, it means both sides are equal. Okay, So if I say 10 is 10, they are equivalent. Okay, so this double equal to sign is different from this first one. This first one is an assignment operator. Okay, while this one is an equivalent operator. Alright, we still have another one, a third one. So later on, we'll get to talk about those ones. Anyway, our focus now, what I'm trying to explain is the AND operator. The AND operator, so let me just say a brief thing about the AND operator. It has a condition, and the condition for it to be true is that both sides should be true. That means the one side, the left side, how will I put it now? Left side should be true and the right side, that's the conditions there, should be true for everything to run as true. Okay, then it means that if one side is false and the other one is true, it will run as false for me. If, for example, one of the right side here is false, the final output will be false. It won't run for me to tell me that this is actually false. Okay, the same thing if it's the other side that is false here, it will run as false at the end. Okay, so for it to run as true successfully, the two sides must condition itself to follow as true for it to run whatever stuff I want it to run. Which what I want it to run is this printf. Okay, so I'm here to put what the printf is. So the printf, let me go back to the question. So the printf part said that okay, and is less than 6 and not 0. That's what I should write here. So let me erase this. So I will write the and is less than 6 and not 0. Okay, so that's it about that. So we're going to run this and see what the output will be. So let me just revise again. So this is our main function. We declared everything necessary to be declared. Oh, this is last. I changed it to last num. So thank God I just saw this bug before. Okay, so as usual, we use our surround. We know how to declare that as our n. So this will give us whatever random number. So now that random number that will come out from this our n, we are going to do the modulus of it. So the modulus of it will give us our last number. So it give us the last digits. Okay, the modulus of whatever number we get will give us the last digits that we need. So this printf is just a normal statement which we want to run as kind of like the heading of how the output should look like. Okay, so the last digits of percent %d, which is the last digits of our n here, or variable n, whatever random number it brings, should give is then the last number will be here, which is our last number, which is the variable I declared after it in this our printf function. Okay, so these are the conditions to be met if that our last number is greater than 5, or if it is equal to 0, it should run this, or if it meets this condition, if these two sides are true, then it should run this for us. So I'm going to print this then. Okay, so there is an error. I forgot to put semicolon in my printf here. So let's run again. Okay, so let me drag this down. So let's look at this together. You can see we have last digits of this random number which came out from this our n, okay, is 9. This our 9 comes from this our second percent d, which is our last num, which we did the modulus. So the modulus of this of 14,909 will give us 9. So and 9 is actually the last number here, as you can obviously see. Okay, so this first line is running this first line here, and then if you notice, then we have an added is and is greater than. Okay, and is greater than, this should be and is greater than 5. Sorry. Okay, and is greater than 5. Let me not change the stuff, but there should be 5 after this greater than. Okay, because if I run this now, I'm going to get another value aside this. That's why I don't want to cancel it and run it again. Okay, so you can see since 9 is greater than 5, it meets this if condition. Because I said if last number is greater than 5, it should print and is greater than 5. That's why it prints and is greater than 5. Okay, so there will be 5 there. So let's run it again and see another output. Good, good, good. So we've seen another random number that comes, and this random number The last value there is 4, okay, which is this 4 here. So now looking at the whole condition, last number is greater than 5. No, it is false. It's not greater than 5. So it's not going to print this. Then to go to this next condition, is the last number equal to 0? No, because 4 is not equal to 0. So it won't print this printf. Let's go to this last condition. Now, is 4 less than 6? It's true. 4 is less than 6. Okay, now, is 4 not equal to 0? True, because 4 is not equal to 0. So these two sides are true. Then we're going to print and is less than 6 and not 0. That's why we have and is less than 6 and not 0 here in our output. Okay, wow. So this is a brilliant example. I thank God this kind of number give us good options for us to do more or talk more of testing each of the else if statements given to us there. All right, so let's take the next tax, please. So tax 3. Now, in this task, we are asked to write a program that prints the alphabet in lowercase, followed by a new line. If you will be using putchar, attempt using putchar twice only in your code. You can actually use several ways. Like, believe me, when I say several, I mean several ways to run the same output. Okay, so there's no one way of print. I've said this the other time in one of the voice notes I sent in the group chat. There's no one way of creating a program. Just keep that at the back of your mind. All right. So there's several ways. So there's no one way. So if you want to write a program now, for example, that prints alphabetical order and all in lowercase, then let's see how to do that. Let me go to my code blocks. Yeah, we don't need all of this anymore. Believe we've talked well about rand, so we are a boss now in terms of that aspect. Okay, so now I want to do the aspect of printing now, printing out ABCD for me. Now, reason, well, since we're talking about ABCD to Z, they are characters, right? And one of my videos, I've talked about characters several times, and I've talked about that table, that ASCII table, all right? So, since they're characters, that means you can declare it as char, okay? So, I can just say, um, okay, since I'm calling A, B, C, D, E, F, all right? So, I can choose to use the for loop to run numbers for me. Okay, so I can use the for loop to run different numbers, and I will start running the number. Since we are dealing with small letter now, I mean small letter A in terms of the decimal value of A in our character is what? Is 97. Okay, so since it is 97, that means I will initialize my counting from 7. I mean, yeah, 97. So I will initialize my counting from 97 and down to Z. Our Z is 122. So it will end at this 122 condition part. Okay, so this is how we're going to go about it. We're going to write for loop initialization I equal to, then your initialization there. I want to use start from this 97, which also means A, okay. Then the condition. So I want I to keep running until it gets to the point that it is 102. So I is either less than or equal to 122. Close the condition, then I'll put my iteration. So I want it to be adding by 1. That is saying 97, 98, 99, 100, 101, 102, 103. So that's how the number will be counting for me. And to be pointing out in alphabetical order for me, to pointing in the characters for me. So that's what that stuff is trying to say there. So I want to use the put char function. We've talked about put char in the previous videos before. So I want to use the put char. I can let me assume I don't even use this put char. Let me use printf. Okay. So since these are numbers, for me to see characters, sometimes I'm going to declare specifier of C. Okay, for me to see the characters. Then I'm going to put the I. Because the I is this variable size. Okay, we even have a variable I, and I'm yet to declare it. So let me declare that variable. So I'm going to say int I, because this I is obviously the integers. You can see 97, 11, 122, the integers. All right. So I think we are good to go like this. Points this. Okay. Um. Then I think they said something in that question. Let me check. Okay, followed by a new line. So after printing all of this, printing the ABCD for me in a one straight line, okay. So it's trying to say then it should print in a new line. So I can still use that print F, then put my new line stuff. That means after it has first run the for loop for me, at the end of it, it should now print a final new line. Okay. That means I'm expecting my output to be like this. A, B, C, D, E, F, blah, 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 blah. Okay. Then when it's done, there will be a new line under it. So let's run this code and see our outputs. Okay, it's showing me that there's an error in my for loop. Did I make a mistake? Yeah, I made a mistake. This should be semicolon, not comma. Like I placed comma here, it should be a semicolon. Okay, good. So let's run this again. So you can see we have A, B, C, D, E, F, G, H, all like that, straight up till Z. All right, so that's just how to go about that. I think let me put, if I put a space in between the specifier, it should change the output so everything will not jam pack. So you can see now it is well spaced in a way. But the question didn't specify that, but I'm just saying it just so you know. Okay. So you can see the alphabetical order all in small letter. Now this stuff we did here, you can still do it this other way without necessarily using numbers. I think so. Yeah, you can still do it that way without necessarily. You can use characters. So I can say small a, which is a character, and we're stopping at Z, right? So I'll just declare my character Z. And since these are characters, so I'm going to change this thing from int to char. Okay. Then it means, okay, this will still remain C. In as much as I want to print something related to letters. Okay. If I'm to change this stuff to D, it means to give me the value in CSCII, which I don't need the decimal value, so I don't need them. So I'll just leave it as C. So it's to print the ABC stuff for me. Okay, so this is just like another way to go about the same stuff. So if I build this, you can see it's still run exactly the same normal way, which I'm expecting it to run. All right. So this is just how to go about it. So aside from us using this printf, that we can then choose to use our put char. If you want to use put char, so that's put char, then put the name of the variable, which is I, inside our put char, semicolon. So the put char will just keep calling itself, like pointing out on the screen repeatedly. All right. So to be calling itself repeatedly till the whole for loop condition is met. So if it gets to this Z, then the next part, our printf will now run its own final new line. All right. So if I run this and see, still the same outputs, and then we have the final new line. But if you notice, this put char has a little limitation, like this, unlike this printf. I see this space I did here. I can't put that same space in this put char here like this. It won't work for me that way, like that. Okay, so it's just a little difference there. And aside from me putting this new line this way using printf, I can still use put char to put this my new line. So I think we've done that in my videos. So what using put char, so what value did we use that signifies new line in that ASCII table? Value of 10 signifies new line. So if I run this and see the output is still exactly the same. So you can see there are just many, there are endless ways of doing this stuff. We can also use while loop itself. Okay, so I just don't want to stress. I don't want to stress myself much on it of trying to show you all the whole million ways you can run the same stuff. All right. So that's just it about that. Or I'm not having double thoughts now. Okay, let me just show you one more way. Let me just show you one more way. Let me just show you one more way. Okay. I want to use while loop. Now the while loop is just like the for loop. Okay, just that the format of arrangement is different. So I'm going to call my I as I'll declare my I as my character A. Then I'm going to write the while function. Now inside that while function has the condition, like just like the middle stuff of our for loop, that middle part, which is the conditional statement. So which is I is less than or equal to So mind you, whenever you're writing character, don't use double quotes. It's single quotes you must use unless you're writing a string. Okay, so don't make that error mistake. So put my brackets, then I'll put my put char, put my I. Then finally, I want it to be running plus plus. So A, B, C, D, one in ones like that, increasing in ones like that. So what it's saying is that the I initialization, we are starting from I, okay? So to start printing, the put char will first start with this I, okay? Once it prints this I, it will do plus plus. So to go to the next part, which is B, then to come to this B, does this B meet this condition? Yes, it is less than B. Okay, then print it out. Then to do again plus plus, that means to print C. Then to go back up, does this condition meet with C? Yes, it is. Z is less than C. Okay, print put chart. That's how it to be circulating, just like the way for loop is till it meets this condition that okay, now it is now Z and equal to Z. So it will then stop the loop. That's why you've noticed it's always Z. Okay, there's no new line here. I forgot to add that new line part. So you want to put the new line, then put the new line after the while loop. So let's just put the new line. That's put char set is 10 as its value. So let me build and run this again. So you can see we have that new line space there. So that's just it about that. I think we've talked so much on this tax theory. And now this tax 4 is very, very similar. I think, yeah, it's very, very similar to this tax theory. So it says write a program that prints the alphabets. Write a program that prints the alphabet in lowercase and then in uppercase, followed by a new line. So we're writing something that will print lower and then uppercase. Okay. Let me just quickly. We can use the same while loop stuff to do the same thing. Yeah, we can use it. Let me just quickly do that. This first one, since we know this first one is for small letter, which is what we started with here. And what the question say again? Write a program that prints the alphabet in lowercase and then in uppercase. They didn't really specify where to stop. Then that means we're putting A to Z in lower, and again we're also putting A to Z in upper. I think that's what that question is trying to say to us. Okay, so let's give it a shot. So that would mean therefore that I can just highlight, copy this, paste it here. We have the big A, I mean small a, then we have the big A, the big Z. Yeah, I think that's it. There's not much thing for us to do. Sorry, this should be big A, not B. Okay, good. So this will run its own course. After this has successfully run, it will go to this next part. Capital letter A will run its own. Then finally our prints, our new line will run. So let's run this. So you can see we have all the small letters first, then the next the capital letters next. So you can see it's very, very simple. Let me just show you another example of the same thing. This time I'm using the for loop which we initially used in that, which we just need to do the same method. We're just going to repeat the for loop again. Which way should I do again? I'm even confused. Should I use character A or should I use numbers? No, you can use anything you want to use. Okay, let me use for this first part. Let me just use character A again. So A, then the condition is that I should be less than or equal to our character of Z. Then the last part is the iteration, that's I plus plus. Okay, so I plus plus. Then lastly, I want it to print. You can use print if you want to print, use print. Okay, let me just use print, and the other one I will use the picture. So I'm just trying to show you mix different ways of doing the same thing. Okay, print this. So this will be I. Now I'm going to run another for loop for the capital letter aspects. Okay, so which is big A. The condition is that I is less than or equal to big Z, then I plus plus, Then this time let me use put char. So put char I. Okay. Lastly, we want it to print a new line for us. So I can just use put char again instead of using printing of new line. So put char 10. So this will still run successfully for us. You can see it's still successful. It just looks shorter compared to using the while loop. Okay, so it looks shorter. And that way of still doing the same thing. Let me just do one quick switch. Yes, we can just see the other way. Let me make this one the capital letter first. I'm twisting the question now. I want the capital letter to run first, and I want the small letter to run after. Let's put this one as a small letter. And this time around, I don't want to use. I don't want to use this stuff. I don't want to use this character, the letter character. I want to use the numbers that represent them. Okay, I think our A is 65 here. So A is 65. Since I'm running A to Z, so our Z here is 90. So 65 to 90. So initializing, we're starting from 65 and I want it to stop at 90. Okay, then it should print. I will leave the C so I can print in letters for me. So let me run this. I expect it should give me the answer I desire. You can see perfect. So we have the capital letter running first and small letter. You can see there are different ways to manipulate this. Okay, so that is just how to go about that task. I think that's enough for testing the several codes. So another last one, number 5, we have that write a program that prints all single digits of base 10 starting from 0 followed by a new line. So we want to write a program that prints, when we talk about base 10 and we talk about single digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are single, okay? I remember I said base 10 are just normal whole numbers. So when you're talking about printing single digits, talking about printing from 0 to 9. They won't signify they're starting from 0. So we want to just print number from 0 to 9. So it's very, very easy to do this stuff. We just need for loop to do that. It's simple for loop. So since we're starting with 0, I'm going to put 0 here. And 0 is a number. We're going to use the int. Okay, so the highest is 9. So I'm going to leave it there as 9. And we are printing numbers. So I'm going to put D. So let me run this. So you can see that's just the answer to the question. Very, very chilling. So you can see 0, 1, 2, 3, 4, blah, blah, blah. Okay, so that's how the code is run. And just so you know, I can modify this condition statement by increasing it to 10. If I increase it to 10, which means I'm going to remove this equal to sign. So I is less than 10 value. In as much that when you get to 9, it still meets the condition there. Curve 9 is less than 10. So it will still run the I plus plus for me. Once when we get to 10, then it won't run that 10 because 10 is not less than 10. Right, so I expect it to give me the same answer. I can see it still give us the same answer. All right, so you can see how we are playing around with several methods of doing one single thing. Okay. Is there any other idea I should use to explain this stuff again? Well, I don't really think so. I think this one is very okay to just understand. You don't need to do too much or make things overcomplicated unnecessarily for us. Okay, let's see if we choose to want to use the put char method of printing out the numbers. What I did with the put char method of printing out the numbers was then still using the same for loop. So I'm still going to put that condition of I equal to. So now what are we printing now? We're printing numbers now, right? So numbers from 0. Let me go to this place. I think we have numbers as characters. They're good. So 0 to 9. So I want to use the decimal. So I'm going to say 48. I'll initialize it to 48 and 9. 9 stops at 57. Okay, so 48, 57, 48, 57. So 48, then my condition I less than or equal to 57. Then iteration sign plus plus. Okay, so I want it to always be giving me the put char value of that. So So it's giving me the character value of what 48 means in our ASCII table, which is 0 and the likes like that as the number keeps increasing. Let me end it with a new line also. So that's bootstrap 10. Or you can use your point F, then put your that new line stuff. Since I'm using put chat more, let me use the point F. Okay, new line. So that's still saying the same thing. So let's run this and see if it still gives us the same thing. You can see it still gave us the same thing because this code is running. We start from 48 and we're using a put char, we're using a character function here. So to tell me what 48 is in our ASCII table, and you can see 48 here means 0, 49 here means 1. So that's how it is. It keeps counting in this I plus plus, adding one till it makes this statement when you get to 57. So 57 is 9 in our table. Okay, sorry, so 57 is 9 in our table, so it has made that last condition, so it will stop iterating once it has met that last condition. Okay, so that's just it about that task. Okay, we have 3 more to go. We are doing well. So write a program that prints the last alphabet in reverse formats. Okay, so write a program that prints the lowercase in reverse following by a new line. Okay, so in reverse following by a new line. Well, what that simply means is that okay, let me read the question again. Lowercase, okay, alphabets, that's what we're printing this time around. Okay, we can still choose to use our numbers here. I think lowercase, that is 97 is our small a. Let me check that table again. Our small a 97, okay, and our z 122. Okay, 122. So I'll put this condition as 122. Okay, since it says reverse, that means it will start from the bigger letter. That means start from Z, Y, and the likes. So that's what it will mean. So that means I should initialize itself. I should initialize it using I as 122. That's what it means. So I can say this is 122, and since this is the last part, that is 97. So that means since we are reducing, then should be not, let me know, that means greater, less than, and equal to 97. Okay, good. We can leave it this way. So I should be less than or equal to 97, which is A. Okay. And our counting, okay, now we are reducing, so it's going to be negative here. So to be 122, 121, 120, 119. So it is reducing. The I will keep reducing till it gets to the reduction whereby the I is, okay, no, it can't be less. If I say it is less than, that means it will still be running infinite loop when it gets to 97. When I say less than 97, it will still running. I mean, to be running for me 96, which I don't need 96. So that means I'm supposed to use greater than here. Okay, so that's the right condition to use. This thing is brainstorming. You have to think well. So that at least the I should be greater than 97. Okay, and since it's greater than 7, that's why even 122 can run, because 122 is greater than 97. Okay, and we're initializing it with 122. All right, then to why this negative sign will keep reducing it by 1. Okay, so keep reducing till it gets to equal to 97, and 97 is that our A. So let's print this and see what it will give us. Wow, yeah, correct. So you can see, so that's just how to go about that. Okay, so we'll print it in a reverse format this time around. Reverse format. All right. You can also choose to update this condition statement by choosing to say, um, let me see. I'm trying to see if I can think of an idea of how to also tweak it more. So since 97 is the last point we are reducing it to, so I can say it's greater than 96. That means I'm going to remove this equal to sign because I don't want it to print what 96 is, because 96 here is giving me a back tick. I don't need any back tick there. So less than this, I think this should still give me the same print out answer. Perfect. So you can see that's another way of also getting the same stuff. Right. So you just reason this condition and everything will run very fine. And you enjoy C programming. Okay. So which question again? Okay, we have the last, second to the last. Write a C program that prints all the numbers of base 16 in followed by a new line. All numbers of base 16 in lowercase. Numbers of base 16 are 1 to 9. Yeah, not 1 to 9. Then from 9 to 15 is A, B, C, D, E, F. Okay. So when you say write a program that prints, so you just want us to use for loop then. So we're just going to use for loop. We're going to use one for loop to run 0 to 9 for us. Then use another for loop to run A to F for us. Then we will print out at once. So this one is even chilling also. Okay, so let's just quickly do this one. Um, should I use? Well, there are different ways. I don't even know which method I should use to solve this one again. Because I'm just confused of many methods to just use to solve the same thing. Okay, okay. Since we're dealing with small letters, let's just use. Let me just. Okay, let me just use this. Let me just use this number stuff. Okay, so let me use the decimal number. So since we're dealing with, I think the first one is 0 to 9. So the 0 to 9 I can use 48 to 57 as the condition, or I can choose. Okay, let me just put it for you first. 48, 57. I'm going to put the equal to sign there. This time around we're increasing. Oh, hold on. No, this should be, since I'm using number, this should be char. I think there's no more error there now. What am I doing wrong here? I have I equal to this. I is an int, since these stuffs are integers. 48. Wait, let me go back. 48 is this 0. 57 is 9. So I should keep increasing to get to equal to this. So plus plus, put char this. Okay. I try to expect this to run. Probably maybe there might be a bug issue with my code blocks. Yeah. Okay, so I'm expecting this to run for me those values. Okay, so let me see. Let me try the printf functions. If I say printf running the digits, no, not digits, but say, let me just percent C and I. You know what? Let's test something. There's this kind of stuff I love doing sometimes. In case you notice some kind of weird behavior going on in your stuff, let me use the online C compiler. So I don't know if there's an issue with my code blocks or not. Open. So we've been using this time stuff since we actually don't need this stuff at all. Only for we can just need for those first earlier ones that we did too. Okay. For iteration, I is equal to 57. Print new line for us. The condition is where I got it wrong in. I shouldn't say greater than 57. I should have said less than. Oh, it should be less than, since it is increasing like this. So 48, 49. So it will be increasing to when we get to 57. Okay, so it should keep running when the value is less than 57. Then when it gets to 57, that means when it equals to 57, it should stop. So if I run this, I believe it should run now. You can see 0, 1, 2, 3. So that was actually my mistake. Okay, so it's not even an error from code block, so I just need to change the sign. Okay, so that's for the first line. Then we can do the other line of our A to F in terms of the hexadecimal stuff. So for I equal to, you can use capital letter A, you can use capital letter B. I'm not sure if they specify whether I should use small letter or capital letter. Okay, lowercase. Okay, let's say lowercase. And then let's use small letter then. To small letter, we have 97, we have 122. So that is initializing from 97, 122, I plus plus, printf. Actually, let me just use put char this time. Put char I. So build this. Oh, what am I doing? I should be. We're talking about hexadecimal. That's A to F. I'm doing A to Z. Okay, so A to F. F. Where's F? F is 102. 102. Okay. So let me run this again. Good. So this is how hexadecimal number are like. That is our output. Another way of running this same code. Let me just quickly show you another way. 0 to 9. Easier, fastest way. Just put 0. We're going from 0 to 9. 0 to 9. Simple. Then make this place as D. So if we run this, you can see it still give us the same thing here. Okay. So this one we're just running it as normal stuff. We're not dealing with any characters here. But this other part we're dealing with characters here. Okay, so we need the ASCII table. Yeah, we don't need it at all. We just do the normal using the push char. I'm just trying to remind you from our previous videos that I've done for you guys. All right. Okay, so we are printing whatever that is in our I, and we know 48 is 0 and 57 is 9 in terms of the ASCII table, the characters. All right. So I'm counting the for loop to be running 48, 49 for me. And while it's running, the question said it wants us to put this comma and it wants us to put space after it. So by a space, okay, and the number should be printed in ascending order also. So this is obviously an ascending order for loop. If it is descending order, we're going to have to switch this. Here will be 57, here will be 48, here will be greater than or equal to 48, here will be I minus minus, just like how we did the other tax, okay. So then for me to put each of those stuff, I'm going to use an if statement saying that whatever I is, okay, in as much as I is not equal to the final number. Actually, that means I'm trying to say in as much as I is not equal to our 9, it's not that we're, remember we're increasing 0, 1, 2, 3, 4. So since it's not equal to it, which is true, okay, then do this if it's true. So what I want you to do now, I want you to put char again. I want you to put this char of comma. Then I also want you to put another char of space for me. Oh, not double. Good. So this is what I want you to do for me. So what is happening now? Once we enter 48, 48 will first enter. 48, Poacher will point it out 48. Then to come and meet this condition, is 48 not equal to 57? True. 48 is not equal to 57. Then next, put this comma, then put this space. Then we're out of the loop part. Then we have to go back to the loop again to meet the next condition, which is as we're going to use then the next one, the 49. Okay, so 49, print out what 49 is, which is 1. Remember, the character for 49 is 1, which is 1. Then come to this place. 49 is 49 not equal to 57? True. 49 is not equal to 57. In that case, put chart this, put chart this. Go again, 40, 50. So that's how the number will be going till when it gets to 57. So when it gets to 57, which the condition is the last part of it, when it's equal to 57, okay, which the condition is true, then come into this place to print the last 57 for me. Okay, now if I is not equal to 57, like as many we're in the last number now, we're in the 57 itself, then it's coming here. If we replace this I with 57, so I said 57 not equal to 57, That's false because obviously 57 is the same thing as 57 now. Okay, so that's the fact. That means it won't run that condition, that if condition for me. That's where the loop then will stop. So let's see an output and explain better what the output is trying to say. Oh, the not, I forgot to put the equal to sign. So that's the not operator. Okay, not equal sign. So not equal sign. So let me run this. What's it again now? Put char an empty character. Okay, I think let me put a space. Okay, good. So that's the space there. Okay, this is not the output I was actually hoping to see. Wait, we have for zero this. Okay, it runs this condition. Wait, 50, 57. I think 57 is the last. Let me check. 57 is 9. Okay, which is um okay, we are increasing it. Okay, 57, 58. Okay, it's okay. Then I plus plus. I'm trying to find where the bug can might be in. Okay. Oh, okay. There is something I noticed here. Remember, this if function concerns this for loop, so I'm supposed to even put it within the for loop. So that is where very good. That's where the need of that curly bracket comes into play. Let me do this. I will need to put that stuff. Yeah, that bracket. So let me just replace this stuff inside it because we have more than one function here. We have the put char, then we have that if function inside. It's only when we have one single function you can choose to ignore that putting of that curly bracket. So let me highlight, cut this, and put it within that same for loop function. Let me just take this stuff up a bit so you can see everything that's okay. We actually don't need this time stuff. I actually forgot to remove it, so we don't need it for a long time now. Okay, so let's run this program again. Of the if, okay, exactly. So this is part of what we call the block scope. So the if condition is under this for loop. That's why we put it this way. All right, so it has run well as expected now for us. Right, so once the condition is done running, then it will return 0 for us. It will build for us. So you can put the new line. That's put char 10. Let me cancel this so you can see the new line. So now that's the new space there. So that is just the output of this. So I believe we understand very well. So if there are any questions, I would like to know how can I get the alphabet to number table? Okay, someone is asking in the chat, how can it get the alpha to number table? What do you mean by to number table? Oh, you are talking about the ASCII table. If you want to get the ASCII table, it's something you can just Google. Just Google ASCII table in C and you'll surely see this table among the pictures of Google Images. Okay, so this part are the decimal, this one's are the hexadecimal. I've explained this thing already in the my previous videos. So just check those videos and understand those stuff better. So since there are no more questions at all in the chat box, I guess we are through for today.